All right. So waiting for Twitch to catch up. Um, do, do, do. All right. So my laptop monitoring Twitch is off to the right, so you're going to see me duck down a few times. See if anyone's got any questions or comments, but aside from that, I should be right here, more or less. All right. So my laptop monitoring Twitch is off to the right, so you're going to see me duck down a few times. See if anyone's got any questions or comments, but aside from that, I should be right here, more or less. All right. So my laptop monitoring Twitch is off to the right, so you're going to see me duck down a few times. See if anyone's got any questions or comments, but aside from that, I should be right here, more or less. All right. So my laptop monitoring Twitch is off to the right, so you're going to see me duck down a few times. See if anyone's got any questions or comments, but aside from that, I should be right here, more or less. All right. So my laptop monitoring Twitch is off to the right, so you're going to see me. So let's get going. Duck down a few times. Yesterday, we did the code kata. I won't spend too much time on that tonight, but I will go over what was involved. My laptop monitoring Twitch is off to the right. So let's get going. Duck down. Yesterday, we did the code kata. I won't spend the factory pattern kata tonight, but I will go over get repo, a simple UI, finding a domain aggregate, creating enum types, topos. So yesterday, we did that video is available. I won't spend the factory pattern kata tonight, but this week I will go over get repo, YouTube, simple UI, finding a domain aggregate, GitHub, creating enum types, topos as well. So yesterday, we did that video is available. I won't spend the factory pattern kata tonight, but this week at the end of the YouTube, we decided to apply that factory. Creating enum types to a brand spanking new game. So yesterday, that video is available. Multi-user factory pattern kata. So that's this week at the end of the YouTube, we decided to apply that factory. Creating enum types to a brand spanking new game. So yesterday, try to make a very basic video is available. Multi-user factory pattern kata. And at the end of the YouTube, we decided to apply tune in to a brand spanking new game for show. You've done the kata to make a very basic video with some exceptions on the too crazy at the end of the we decided to apply tune in to a brand spanking new game for show. You've done the kata to make a very basic video with some exceptions on the too crazy at the end of the audio we decided to apply tune in to a brand spanking new game for show. You've done the kata to make a very basic video with some exceptions on the too crazy at the end of the audio we decided to apply tune in to a brand spanking new game for show. You've done the kata to make a very basic video with some exceptions on the too crazy at the end of the audio we decided to apply tune in to a brand spanking new game for show. You've done the kata to make a very basic video with some exceptions on the too crazy at the end of the audio we decided to apply tune in to a brand spanking new game for show. You've done the kata to make a very basic video with some exceptions on the too crazy at the end of the audio we decided to apply tune in to a brand spanking new game for show. You've done the kata to make a very basic video with some exceptions on the too crazy at the end of the audio we decided to really fast. Tune in, brings a new game for show. Alright, done the kata, becomes very nothing. Video with some exceptions on the user-based settings. So, featuring some audio training. We decided to really fast. Tune in, brings a new game for show. Alright, done the kata, becomes very nothing. Video with some exceptions on the user-based settings. So, featuring some audio training. We decided to really fast. Tune in, brings a new game for show. Alright, done the kata, becomes very nothing. Video with some exceptions on the user-based settings. So, featuring some audio training. We decided to really fast. Tune in, brings a new game for show. Alright, done the kata, becomes very nothing. Video with some exceptions on the user-based settings. So, featuring some audio training. We decided to really fast. Tune in, brings a new game for show. Alright, done the kata, becomes very nothing. Video with some exceptions on the user-based settings. Alright, test 1, test 1, 2. We decided to really fast. Tune in, brings a new game for show. Alright, done the kata, becomes very nothing. Video with some exceptions on the user-based settings. Alright, test 1, test 1, 2. Playing in the browser. Whew. Alright, test 1, 2. Alright, rookie mistakes. Okay, so to catch us back up with everything I said before, we're going to be applying the factory pattern we did in yesterday's code kata to a game called MUD-Z, which is a multi-user dungeon styled after some of the old school Telenet games like Major Mud and Telarena. And just to recap super fast, the kata, which is the videos out there and the Git repos out there, went through the steps of creating a UI, creating a factory pattern to create some POCOs, and some of the benefits of that. To see that in action, we went ahead and looked at applying it to this text-based game. All right, thanks for the feedback. Looks like everything's good now, so gotta keep driving forward. All right, so to demo the factory, we created a guy named Gary and said, hey, player factory, create us a player with the name Gary of the player type politician. So let's go into the create method. And very simple factory pattern. We're going to return a type of iPlayer. We're going to take in the string name, and we're going to take in the player type we want. We're going to feed that type into the switch statement, and then return back. We only have support for Medic and Army Vet right now, and then we'll throw an exception for anything we don't support. So for our first step, let's go ahead and extend this out to support all of our player types. And for the classes we haven't created yet, we're going to create those POCOs as well. So we don't have a carpenter yet, so let's go back into our player domain. Let's go ahead and create a new class. Let's call it carpenter. All right, it's going to be a public class carpenter. That's going to inherit from our player base class. And we are using ReSharper. ReSharper is going to be the only tool that we use that isn't free. Otherwise, you can use GitHub to grab the Codecadder repos, and you can grab Visual Studio Community Edition to code along. But ReSharper is such a great tool, and kind of a crutch. It's hard to code without it, and it definitely compensates for the minus 10 IQ points that you get from doing things live and during demos. So ReSharper is telling us that player, being an abstract class, has methods and properties that must be implemented. So let's go over to player and see what that means. Alright, so player is inheriting from base game object, and on top of that is applying the contract iPlayer. So this is a bit of a rabbit hole, but it's definitely important, and is going to be a big part of what we do moving forward. So I'll drill into it. So then in base game object, we're saying that any object in the game has to obey the contract iGame object, and has to implement, or by default will implement, a name, dexterity, hit points, a game object type, whether it's destructible, and then how to take damage, and also how to repair. So when we derive player from that, we get all of those properties, and then on top of that we're saying, okay, so player has to abide by the base game object contract, but we also want it to abide by the player contract. And so the player contract, we're saying any player in the game, in addition to all the base game object stuff, also has to have a player type, and then these 5 methods. Hey, Surtu, glad you're back. You'll probably see exactly where we left off yesterday, so nothing new for you. We're just walking through the construction of the game so far, and also extending out the factory so that it will accommodate all of our player types. So when we come in here and we create a player, we're saying that we want a specialized type of player. Meaning, for example, the Army Vet. The Army Vet's going to inherit all of the game object properties, but we're going to have to tell it how an Army Vet would repair something, or how an Army Vet would attack, or how an Army Vet would heal, or negotiate. So we're doing that for all the types, so they all have this specialized behavior, but they're all derived from the same base object, which allows for polymorphism and a lot of more advanced game mechanics later on down the line. So we're setting ourselves up for that. So to go back into Carpenter, we're going to let ReSharper do its magic and just implement our missing members. This is a dialog you're not going to see in the base Visual Studio install. It's part of the ReSharper plugin. It's just asking us which of our missing members do we want to bring in. I'm just going to say all of them. Okay. And so we also need to have a constructor for Carpenter. And we're doing this inside of every implementation. So we're saying that whenever a carpenter is instantiated, take in the name, apply it to the name property, which we're inheriting from the base game object, and then also set the player type to carpenter. Right? So if we haven't gone too advanced for a basic example, we can expand on this concept of abstract classes, where inside of player, we can give player a constructor. We can say public player takes in, let's say, string name, and sets the property to name. So if we do it this way, we could make it constructed. So ReSharper is really great, and it gives you a lot of suggestions. Some are necessary, some are not. Some are for the context, some are wrong. So it's really good to challenge ReSharper whenever, or just understand what it's suggesting and why. So we can make it protected here. We're not going to for the sake of keeping things simple, but this is going to be considered a base constructor. So when we go into, let's just say our carpenter class, for example, it's going to give us a red squiggly because we don't have a parameter list, but we can add a base initializer. And when we do this, we're actually saying call the base constructor inside player and pass in name. That makes this call unnecessary. So if we wanted to bake in behavior, we can. And it comes in handy sometimes it doesn't, but it gives you the choice, right? So we can do it here, but we don't have to do it here. So it'd be the same idea by passing in these methods. Oh, I'm sorry. So let's do this. Let's do this. And let's tidy this guy up a bit by giving it also. So I mentioned yesterday that whenever you create a constructor and give it a parameter, you remove the default constructor that's provided to you by the compiler. So if you want to have a parameter-less constructor, you have to define it explicitly at that point. So that's what we're going to do here. So by tidying up our player abstract class and coming back over to ArmyVet, we have the option now, right? We can create an ArmyVet with no baked-in instantiation and all of it, and it does nothing. Or we can go ahead and utilize some of our baked-in functionality from player by calling the base constructor. So hopefully not too far down the rabbit hole, and I just wanted to showcase a little bit more about abstract classes and hopefully get the point home about their power and their kind of their functionality. All right, so back to the stemming out. So I'm going to create a new carpenter. I'm going to pass into it name. Case player types. So I got a medic, an army vet, a carpenter. I'm going to do a mechanic. I don't have one yet, so we'll do the same thing here. A little bit faster. Let's go implement those missing members. All right, now I have a mechanic. So while the benefit of doing these things is that proficiency, the ability to do it really fast, we're still creating essentially the same object over and over again, which you really can't get around. There's some, I mentioned the strategy pattern yesterday, and it's something we're going to look at as far as making these things more maintainable later on. But sometimes, you know, this kind of low on the totem pole programming is just par for the course, unfortunately. So new mechanic, name string. All right. And it helps me to kind of do these things in order. Sorry, I'm fighting allergies and currently losing, but I think we're around that bend. I think we're getting better now. All right, so let's do our politician. And honestly, at this point, it should be nearly muscle memory. Create a new politician. Put the access modifier on as being public. Inherit from the base class player. Implement the missing members. Satisfy our contract. And then create a constructor that takes in a parameter of string and then passes that parameter into the base constructor for assignment. Oops. And say base, write base. All right. And then we're going to set our player type as politician. So go back over to the factory and finish this guy off. Pass in a name. So we've now accounted for every possible player type that we have, but we still want to leave the default throw new not implemented exception just in case later on we do extend the types in the enum, which is here, but we don't do it here. Again, we want to write everything as if we're writing an API. We want to bake in the same kind of checks and assurances to anyone implementing an API when they've done it incorrectly or done something that's not supported. So we never want things to fail silently or to behave unexpected. So while passing in a player type that's unsupported produces an exception, that's the expected behavior. All right. So coming back over to our program, we now should be able to do a variety of characters. We can say Beth is let's go to factory and then create Beth, and Beth is going to be of a player type army Beth. So we can create all these characters, but we can't really do much with them. And to be honest, we probably won't. What we're going to do instead is keep practicing the factory pattern, which is the theme of this week, which is a creational pattern. And then we're going to extend that naturally next week with probably a behavioral pattern, so we can start giving our characters behaviors. And then we'll practice giving different player types different behaviors and see how that works. And really start to see that polymorphism in action, where we can do this very straightforward call to get any type of player, but based off of this parameter, get wildly different characteristics for that player. But at the same time, making all of these calls uniform. So both Gary and Beth both have access to this repair call, but maybe when Beth calls repair, it succeeds. It succeeds with a +1 because she's an army vet and she's pretty skilled. But Gary's fails, and it fails every time because this politician, not saying no politician's done to repair things, but Gary is worthless. And every time he tries to repair something, it's going to fail. All right. So with this in mind, let's look at other things that we can create. We've done player. Another object, and we'll go to object types. So we said the object types can be player, NPC, monster, inventory item, and environment object. We've done player as its own domain. And now we're going to just walk down the line. We'll do NPC next. So add a new folder for NPC. And we'll just do it that way. We're going to do very much the same thing we did with player. We're going to start off with a contract. We're going to say new item, interface. I'm going to say I NPC. Have the access be public. And then we're going to decide what it is an NPC should do, right? Probably very limited. So we'll say that any NPC should be able to speak or greet. Let's just say that. Void greet. Any NPC should be able to, let's say, process commands. These might change later on, but at the very basics, if we came across a shopkeeper, we'd want to be able to greet that shopkeeper and then give that, in a programmatic sense, give that shopkeeper a command and have something be the result. Whether the result is a response or the result is an action. We want them to be able to do that. So we're going to say greet process command. Now, while a response might be, the response to a command, we might also want NPCs to do things of their own volition. So we're going to say, another one's going to be respond. Alright, and we'll just stop there for the NPC because we don't really have a game yet. We don't really know what we want the NPCs to do, but we've got something in there. And something ain't nothing. Alright, so next we want to create a base NPC. Something for all their NPCs to inherit from. So into the class, make that an NPC. We're going to say public NPC is going to inherit from I NPC. It's going to tell us that we are in violation of the contract because we haven't implemented those three methods. The other thing that we want to do is go ahead and make this as a game object. So we're going to inherit from base game object as well. Because again, everything in our game is a game object. And creating that kind of floor is really going to help out when you want to do cleanups, extend things. It's good to know that everything derives from one base type. Alright, so just like we're going to make this an abstract. Now, just like our player abstract class, we're going to give it a default constructor that takes in the name. We're going to assign the name to be name. So we're already seeing again here that we're taking advantage of name being an property of base game object type. Now let's stop for a second and double check. One thing we didn't do is we never set a game object type. So this is kind of just hanging out there as null right now. So let's go back and fix our player. Inside our abstract class, we know that, name's going to be name, that's fine. But what we also want to do is say that the game object type is equal to player. And it's giving us a red squiggly because inside of our base game object, made that a private set. Let's go ahead and make that it's a regular old set. And when we do that, we're going to go ahead and, if this is public, then that set's going to be public. Unless we declared otherwise like we did here. So now the red squiggly goes away, and we're back to where we need to be. Alright, so these are both players, and then inside of our NPC, we'll do the same thing. Game object type is equal to NPC. And then we'll create a parameterless constructor that just sets the game object type as being game object type NPC. And to a point, to a logical limit, it's good to have as much information available to you in the calling layer, which is how we're going to refer to anything that's going to consume our API. It's good to have as much information available to you as possible. Otherwise, you're coding against a black box. You're making assumptions. But it's good to say that Gary we've exposed heal, move, negotiate, and player type. It's nice to be able to know what that player type is. Okay. I think it's looking better here. Inside of, yep, politician is fine. Alright, so we got our base NPC class. When would I consider using constructor chaining? You know, I don't have a lot of experience with it, aside from the basic inheritance that we have here. I have done some stuff with static constructors, things that I want to be processed before anything else. But what I will do is make a note clearly don't even know. I don't even know what the best way to do that in C# would be. So that's some homework for me. Thank you, Made of Candy. What's learning? I'll just go ahead and look it up now. Oh. Okay. You know what? For my needs, I wouldn't. Oh, I see. Yeah. Which is fair. It's totally fair. I don't do a lot with constructors outside of the basic implementation. I do accept a little bit of code repetition. Just because when I do my pattern implementation, and we'll see this inside of the strategy pattern when we get there. For me, in the way that I think, it's just easier to map things out this way. So I take the hit, I guess, with a little bit of extra code. It just ends up being easier for me. But I could be wrong, and it could be a learning point. So I'll look it up, Made of Candy, and that's what this is for. This is definitely for us both to learn. So I could add to my toolbox. So yeah. All right. And anything you want to add more in chat to kind of Yeah, educate me. By all means, throw it in there. Or all of us, really. Alright, so I don't really know what kind of NPCs I want in the game. So to brainstorm that, I'm just going to go ahead and add a new enum. Let's do NPC types. Alright, so it's going to be a zombie game. We know that. It's going to be a survival game. And I do know I want a townsperson. I do know that I want a shopkeeper. And I do know that I want, maybe not a sheriff. Do I want a distinction? Let's do deputy and sheriff. So 4 NPC types. These are going to be the 4 NPCs you can interact with. And we might extend that, might drop it back down, but for right now I think 4 is good. No, sir, too. No screenshots. Just something we're writing on the fly. It's going to be text-based, and to be honest, it's really just a place to practice out the katas we do every week. So if it ends up being a good idea of any kind, I'll definitely write up some storyboards, some basic intro text and such, just to get everybody acquainted. But this is going to be a text game. Really, not much to show aside from that. All right, so NPC types, we got those 4. Again, we're just following the same thing we did over here in player, and the kata as well. Once we decided on our aggregate, in this case NPC, and then we created our contract, we created our types. Next thing that we did was to create the POCOs to feed the factory. So let's go ahead and do that. So I'm going to create a new one. Called townsperson. Did I camel case that? I didn't, but I want to. Or do I? We'll just do it. Public class townsperson is going to inherit from NPC. Alright. Looks good. Alright. There's something else I wanted to do. Did I? Give me 2 seconds. There was another point I had in my notes. I wanted to bring up. I don't know if I did. Alright, not super important. Alright, so inside of our base, we didn't make these abstract. I don't know if we want to. Is there anything that an NPC would do that would differ from NPC? And if nothing differs, then why have different concrete implementations? Let's go back to our base game object. Instead of our base game object, we have the virtual methods take damage and heal. So I think it's going to be something that we want our NPCs to do differently, is take damage and heal. Now, I'm curious because I'm not sure if inside of an abstract class that's inherits another abstract class, if we can override a virtual method and make it abstract. So let's see what happens. No, it just mixed back over, and it really was, that's fair. ReSharper is not happy. And called it a redundant method override. That's interesting. I'm not really sure why it cared that much. Oh, interesting. So it shouldn't have cared, but ReSharper saw this call to the base take damage and decided this entire method was redundant, which is smart, but So, but we do have a call to make here. The way I've done this in the past, and I'm going to call you out, Made of Candy. The way I've done this in the past is I will have a public abstract void method here that's very similar to my my base implementation of take damage. But not called take damage. That will make that. And then inside my concrete implementation, I would implement process damage, and then I might call take damage on top of that. Not sure that's the best way to go about it. Let's think on this for a second. All right. What we can do, and I might come back to this, we might come back here, make this abstract, so we're not providing any default functionality. Make that abstract. So if we come back into base time object, okay, we might do that. So, yeah, I'm going to agree with Made of Candy on this one. So we're going to go ahead and make the abstracts in our base class for base game object. What this is going to force, though, this is going to force that every game object has to implement take damage and heal, which is fine. And you'll see that NPC is not in violation of this, even though it doesn't implement those two methods, because it's the responsibility of that concrete implementation, whatever it is, to satisfy the contract. So that's why we come into townsperson, and the only thing that it cares about is implement the missing members. Okay, so we have to also come back and fix our player classes as well. Which, honestly, we'd want to do. We'd want every player type to do those things differently. Presumably, I really bash on politicians, and I don't mean to, but presumably a politician's going to be less resilient to damage, or maybe status effects that the damage could cause. Like maybe a politician gets stunned more easily when they take damage than a medic or a carpenter, right? So we do want those to force the implementation. All right. Let's see what we got. All right. So far for our NPCs, we have created our contract. We've created our abstract base class. We've got our types, and we've got our townsperson. Let's go ahead and create shopkeeper, deputy, and sheriff. Since we aren't really doing much here, and we've only got about 10 minutes left in the stream, let's go ahead and just do that. Normally, I'm a huge advocate for, if you're doing a kata or something, type it out, get a good muscle memory going. But right now, And shopkeeper. All right. And just to complete the factory kata, let's go ahead and add a NPC factory. And so before, we're just going to do a static method, public static return of type I NPC, create, string name, and then NPC types, NPC type. I'm going to do a switch on that. And for the case of deputy, return new deputy. In the case of sheriff, well, let's go back and tweak this just a little bit. NPC. Did we forget? Let's close out some of this noise. Yeah, NPC. We forgot to say that as part of this contract, we want NPC type to be required. Alright, we're back to where we want to be. NPC type equals deputy. Copy that. Go to shopkeeper. Let's give him or her, the same treatment. Alright. Townsperson. Alright. Back to our factory. Let's pass in that name. Let's patch up our sheriff with our constructor. Right. And then, so we've got something for all of our types, but we also want to give our default as being a throw new not implemented exception. Sorry, this type is not supported. Alright. Let's get rid of our using statements we're not doing. Just going to clean it up a bit. So, we've gone through our factory pattern kata for a second time with NPC, and we now have a factory that we can use to call non-player characters. To wrap up and do just a little bit of cleanup, because we had said we wanted every game object to implement that take damage, which means that this guy needs to implement those members because he's our player. Let's go ahead and close all but that. Alright. Our army vet needs to have those as well. And we know what we need, so we're gonna save some keystrokes and copy that. Carpenter also needs them. Mechanic. Medic. Which is sorry, I almost lost my train of thought. Alright. Alright, array for memory. So it builds. And this is a great point to Tomato Candy. I didn't know about the chaining of constructors, but I think it piggybacks on this idea. We've only done, sorry, 2 domains, and we already have quite a few files. And we just saw that when you go back and make an architectural change, and you have to go back and copy and paste the same code in various places, anything that you can do to architecturally to limit that is going to reduce your maintenance quite a bit. And so I'm look up the constructor chaining and see if it's something that we can work not only into the kata but also into this architecture, just to reinforce the point that it starts here, right? All that technical debt you might see later on in the project, all of that cursing, you know, to make even a small change to something. This is where those evil little nuggets get buried. So we want to be really careful when we do these things, even the simple stuff, that we're doing in a way that's going to be maintainable. Some of that's going to come up later on with different design patterns as we implement things like, even like facades and the strategy pattern, which I talk about a lot, the decorator. Things are designed definitely to flatten out the technical debt so that 6 months from now, when you've got 20 folders and 200 files, that making a change to the system is logical and is straightforward, and you'll start saying things like, what's my migration strategy going from this version to the next? What's my upgrade path if I need to go from one version of .NET to the other? I need to deprecate some calls. I need to replace some calls. What does that look like? And you'll feel a lot better if it's a very, very small amount of work for a big impact. All right, so that's an hour on the nose, actually. I guess I was a minute or two late to the stream, but I'll do some homework on the things we talked about, and this weekend at I'm guessing probably 8:45 in the morning, I'll post, and that's going to be about an hour and a half, depending, going through the kata and going through this code and trying to clean up a little bit. If something like the constructor chain is something we want to add in to the kata to make sure that it's always something we're thinking about, or if we want to introduce abstract classes to the kata, since they come in handy nearly immediately, and make sure it's something we're also practicing. I'm improving, and hopefully you guys are improving and learning something as well, but that's what Saturday is going to be for. So that's about it. I want to thank everybody for tuning in. I want to thank Made of Candy for the good advice. I want to thank everybody up front for helping me get the audio sorted out, even though it was just me playing myself in the background. And I'll check chat, and I'll hang out for a second to let the stream catch up if there's any questions. But aside from that, that's it. Thank you. Yeah, hey Mad Candy, great thought, and I'm hoping that's also going to be a Saturday thing. So probably me talking a bit less and doing some refactoring of the code, and doing this a whole lot as I'm thinking and chewing on things, hitting the internet and searching for stuff. So you know, probably a more boring show, but it'll be good to kind of sit back, collaborate with anybody in chat. So if you want to hang out on Saturday, and we can spitball ideas and really get into the nitty gritty of it, that'd be great. But yeah, definitely what I think Saturday's going to be a fun day for that kind of stuff. So thanks for all the feedback. All right, and with that, I'm going to go ahead and stop the stream. Head over to Reddit and Watch People Code, and you can add comments there to this link. And I'll be adding videos to YouTube as well and posting them for recordings. All right, thanks again.